Hi children, this is Venkateshwarlu, mathematics teacher, going to explain you 10th standard maths. So let us discuss about the first chapter, that is real numbers. So in the real number system, before going to discuss this topic, let us have the discussion about number system. As we know that in the number system, natural numbers, set of natural numbers denoted by n. So counting numbers are called natural numbers. What are they? 1, 2, 3 and so on, as you know that. Next, come to the next set. Natural numbers including 0 are called whole numbers. Next, besides whole numbers, if you add negative integers or negative numbers, then it is called integers. So integers also called as real numbers. So these integers denoted by so on, minus 3 comma minus 2 comma minus 1, 0, 1, 2, 3, so on. These are called integers. Next, the next set is rational numbers. Set of numbers which are in the form of p by q, where p and q are belongs to integers and q not equal to 0 are called rational numbers. And one more set is exists which is not rational, is called irrationals, denoted by q dash or sets s. So which is equal to what? What is the format or symbol of irrational numbers? Root n, where n is not a perfect square, right? So now come to our topic. In the real numbers is nothing but union of rationals and irrationals. Real numbers is the union of rationals and irrationals. In that, rational and irrational, how to find divisions using Euclid division lemma. That is the first concept. Next, if you come to the second one, by using this division, it extends to how to find HCF or LCM. If any two numbers given or any two real numbers are given, we can find their HCF and LCM using this Euclid division lemma concept. Next, one more concept is rational numbers, that how to represent or how these rational numbers are terminating or non-terminating. So rational numbers two types, one is terminating decimals, one is what? Non-terminating decimals. Non-terminating decimals, where non-terminating decimals are repeated, but whereas terminating decimals are not repeats, it ends after certain number of digits. Now come to the concept of irrational numbers. In this concept, we are going to prove how given numbers are irrational numbers. Whether they are irrational numbers or not, to prove, we will take the contrary and we will finally prove that given numbers are irrationals. So the concept of rational and irrational gives us what? Real numbers. That is our today's topic, real numbers. That is the first chapter in 10th standard. Here, besides this real numbers concept, one more concept is included in the chapter, that is logarithms and their properties. Based on the properties, we are going to solve the problems based on logarithms, whether expansion of logarithms or any expansion is given, we can write them in short form. So that is the main theme of this lesson, real numbers. So if you observe, first exercise based on this 1.1, second exercise based on these two concepts, that is 1.2, third exercise based on rational numbers concept, whether they are a terminating or non-terminating concept, and irrational is fourth. Next, this is logarithm is fifth exercise. So all the 5 exercises based on these 5 concepts. In each and every exercise, new concept is included. So that is the reason we have to concentrate on every concept, especially Euclid division lemma. So what is the lemma? If you observe, A is equal to BQ plus R where A and B are any two positive numbers and Q is some integer or some quotient and R is remainder which is less than B. Let us discuss about the first concept, that is Euclid division lemma. So what is the statement? Let us see here. Let A and B are any two positive integers. Okay. Then there exists a unique pair of whole numbers Q and R. Satisfying this rule, where A and B are what? Integers. We have considered Q and R such that A is equal to BQ plus R, where R lies between 0 and B. Remainder always should be less than its divisor. Okay. So it should be greater than or equal to 0. So now if you consider A equal to 26 and B is equal to 4, then what can write this 26? 26 can be expressed as 4 into 6 plus 2. 4 6 are 24 plus 2 26. So any number, any integer can be expressed according to the Euclid division lemma. So what is the use of this Euclid division lemma? Whenever you are finding like this, when you write any number in this format, the last divisor is called its HCF. So that is the advantage of the division lemma. Without a regular process, by using this lemma also, we can find HCF of the given two numbers. So let us discuss the fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? Here, every composite number can be expressed, nothing but we can factorize it as a product of primes. In this factorization, it will be always unique. That means we will get always a similar factors. Apart from the order in which the prime factors occur. Order is not criteria. You may get a different order, but ultimately you will get same factors in its factorization. Let us consider one example. Suppose composite number, we consider it as 36. Let's find its factors by using different methods. First method, as you know that 2 18s, 2 9s, next 3 3s are, next 3 1s are. So what are its factors if you list out now? 36 is equal to 2 into 2 into 3 into 3. So what are the factors you got in this case? 2 2s are 2 square, next 3 into 3 in the sense 3 square we can write in its simplest form. Now the same number we can also find its factors by using tree method. Okay, here we can write it as 4 into 9, 4 9s are 36. This 2 we can write it as its factors as 2 into 2 4 and its factors 3 into 3. Right? Otherwise we can also take its factors. Now 36 you can see here in this case what you are getting 2 into 2 into 3 into 3. So it is also getting as unique prime factorization as we got in the earlier. See that 36 is equal to 2 square into 3 square. Suppose one of your friend is done in this way, that is, what can I write? 12 3s are 36, 3 into 12. Next 3 4s are 12. Next 2 2s are. So in this case also we are getting, what are the factors we are getting? 3 and 3. 3 into 3 into 2 into 2. So which is equal to 3 square into 2 square. Whatever the order might be, whether you are getting same factors not, let us observe. Here also we got 3 square, here 3 square, here 2 square, here also 2 square. Order is not criteria. Apart from the order in which they are occurring, that is not criteria, but whether they are getting same unique factors or not, let us see. In this case got the same factors. Here also we got the same factors. In this case also we got the same factors. So that if you consider any composite number, not only 36, any number, we will get the unique prime factors for that particular number. So that this is true for all. That's what we call this as fundamental theorem or basic theorem of arithmetic. So once again, recollect that theorem. Every composite number can be expressed or factorized as a product of primes. What are these numbers are said to be? Prime numbers as a product. Okay, and this factorization is always unique apart from the order in which they occur.